Hi, and welcome to episode 2 of the screencast series on getting started with the JSP wrappers for Kendo UI. In this episode, I'm going to work with a database that has a table of employees. It's data that you may have seen before. First, I'm going to look at just how to retrieve all of the data from the table and display it inside of a Kendo UI control. And then I'll take a look at a somewhat more advanced example that uses Kendo UI to display the data in a hierarchical relationship. Now, I'm not going to be using Hibernate or any other ORM framework. I'm just going to be using plain Java SQL objects because I feel like it helps us focus on the basics of server communication with Kendo UI. Now, of course, in production, you're most likely going to stick with whatever your team is currently using to interact with the database. And the Kendo UI JSP demos themselves actually ship with Hibernate support, as well as including a little bit of magic for you to make those queries a whole lot simpler. So I'm pretty much picking up exactly where I left off in episode 1, with the exception that I've created a navbar tag so that the page that I'm building doesn't look so boring. And also I can use this navbar again on other pages I create in subsequent episodes. First, I want to create some sort of data access layer for this project. I'm going to go ahead and create a package called repositories. In that package, I'll create an employees repository class where I can put all of the methods that I'm going to use to interact with the employees table in the database. Since I'm using a file-based SQLite database for the demonstration, there's a little extra code that I need to add to get the location of the file from the web server. If you're using a database server, you probably will not need to do anything like that. I want this class to return a list of employees, and so before I can do that, I need to define an employee in this project. I'm going to create a new package called models, and I'll create a new class in that package called employee. And right now, I'm not going to be returning all of the employee database table fields, so I'm just going to use the employee ID, and I'm going to concatenate the first and the last name to make a single name field for now. I can now go back to the employees repository class and create a list employees method, which will return a generic list of employees. I'm going to use prepared statements to query the database, and I'll return the results into a results set. Then I can iterate over that results set and insert a new employee into the employees list that I'm ultimately going to return from this method. Now I still need a way for Kendo UI to interact with this employees repository. As I discussed in episode 1, I have to remember that Kendo UI is in the browser and the data is on the server. So how do we communicate between the two? What I can do is make a URL that will return the data from the server whenever that URL is called. The data can be returned in several formats, but it's most commonly XML or JSON. I'm going to be using JSON as I think that it's easier to read and understand with the human eye and makes a little bit more sense to me. So to be able to send back data from the server as JSON, I'm going to add in a third-party JSON library to my project because it makes the formatting of objects to JSON very, very easy. I'm going to create a package for all my servlets called API, and I'll create a new servlet inside of that package called employees. And I'm going to modify the URL path a little bit to be API/employees. Not necessary to do that, but for my demo, I would like my endpoints to be off the /API URL. I'll add an instance of the employees repository object at the top of the class, and because I am using file-based database, I'll go ahead and pass down the location of that database to my repository class. Now I can implement the doGet method. This method will be called whenever the API/employees endpoint is visited either by a browser or by Kendo UI in the form of Ajax. In this method, I only need to call list employees from the repository. I can then use JSON to format this list as JSON and write it to the response. I also need to include in the response that the data that I'm sending back, the type of data, is JSON. If I get any errors, I'm just going to return a 500, which indicates a server error, and then I'll print the stack trace on the server so that I can actually see what happened. Now I'll restart the server and visit this URL. And you can see that we have all of the employee data and it's formatted as JSON. Now that we have all the proper plumbing in place, I can hook Kendo UI up to this list of employees. I'll keep using a simple drop-down list, but I'm going to get rid of the static list of things. And instead, I'm going to specify a transport on the data source, which will let me specify a URL to read. Now, you might have guessed it by now. We will be using the API/employees URL to get the data. I'm also going to tell the drop-down list which field on my data source has the text to display and which one will have the value to set as the item. Now, if I refresh the page, I can see the drop-down list has the employees in it. But how did that happen? If I open the browser tools and switch over to the network tab, I can see the request is made to the API/employees endpoint by Kendo UI, and the JSON is returned. Kendo UI then reads in that response and creates the drop-down list items for us based on the configuration values that we specified. We're now able to return data from the server and display it in a Kendo UI widget. But what about those special or really odd circumstances? We have one right now, in fact. Each employee in this table is actually related to another employee in the same table by virtue of a reports to field in the database. This is called a hierarchical relationship. Kendo UI has several ways to deal with data that are structured this way, but the most common way to do it is to use the Kendo UI tree view. The first step in using the tree view is to get the data in the right format. Now, I currently have it returning all of the employees, but what I really want is only to return the employees who have the manager that I specify. That allows the tree view to lazy load the data. What lazy load means is that only the data that we're currently looking at is what's returned from the server. So as we expand nodes in the tree view, we need for the server to send us that data just in time. Now, this is not only great for bandwidth, but it also increases page performance as only the data that needs to be seen is actually put in the page. By default, the tree view is going to expect me to return in the first response the top level node or nodes. In the employees table, the top level employees have a reports to field that is null. So I can modify the query to return me just those employees. As it turns out, there's only one. Everyone else either reports to this person directly or via some other employee. Now, how do we tell the tree view what value it should send to the server when requesting more data? The hierarchy is specified in the data source schema hierarchical model. Here, the data source is going to want to know two things. Number one, which field should it use to request more data? This is the ID field. And number two is, how does it know whether or not the current node actually has any children or the current employee has any employees reporting to them? The ID field is just set to employee ID. The has children field is one that I haven't defined yet, but I'll enter it in as has children, and then I'll add it to the model as a Boolean value. Over in the employees repository, I need to handle this new ID parameter that the tree view is going to pass. I'll add a parameter of ID to the list employees method, and then check to see if it's greater than 0. If it is, I'll set the where clause using that ID. If it's not, then we'll just assume that the top level element was requested, and we'll set the reports to field to null. In order to determine if this employee has any children or employees, I need to check and see what the count is of any employees that have this employee's ID in their reports to field. I'll then use this value to determine whether or not to set the has children value on the employee model to true or false. In the servlet, I need to handle the parameter that Kendo UI is sending over. I can read it right off of the request and give it a value of 0 if nothing was passed. I'll pass this ID to the list employees method, which should then return me only the records that the tree view currently needs to show. If I refresh the page, I now have a tree view with only one person in it. If I expand that person, I see all of the people that report to them. If I open the developer tools and examine the network traffic, I can see that when I expand a node, Kendo UI makes a request to the server for the necessary data. And notice that it only does this one time per node. So after making the initial request, it keeps the data in the page so that no unnecessary requests are made. Let's review what I talked about in this episode. I set up a data access layer that returned a collection of employees. I created a servlet to respond to URL to return that collection of employees as JSON. I configured Kendo UI to send requests to the server by specifying the model hierarchy, and then I read the parameter that Kendo passed to the servlet and applied it to the query. So much has been covered in this screencast, and you are well on your way to mastering Kendo UI at this point. In the next episode, I'll tackle one of the most widely used controls in Kendo UI, and that's the grid. I'll talk about how to provide a complete editing interface and what it takes to make sure that the changes that are made in the browser are persisted in the database.